Hello everyone and welcome back to another video. Today we'll be taking a look at another British Informatics Olympiad question, and today we'll be taking a look at the 2022 paper and the second question from it. Okay, so this is one of the longer questions, and pretty much half of the difficulty in this question is just understanding what exactly they want. So I won't leave you to read the question by yourself. Like I'll explain what every line means, and then I'll explain each function as we read the question, because I think that makes much more sense, and that's much easier to understand that way. Okay, so pretty much what this initial section is basically saying over here is it's basically describing some sort of complex which we have, like some sort of building, and then it's basically represented by lots of connected rooms, and we need to basically model a spy moving through these rooms. So the first part of the question is basically telling us how exactly the spy moves, which is this part. It tells us how the spy moves, and then later on in the question, it basically tells us what decides the order in which the moves which the spy makes. Okay, so we'll tackle this particular part first. Pretty much, the highlighted parts are the ones which are definitely very key. So each room is uniquely identified by a letter, which is important. So we know exactly how we're going to represent each room now. And then we also need to keep track of whether they're visited an odd or even number of times. So we should also have some sort of visited array, and they should keep track of whether they've done it an even or odd number of times. So over here, I'm just going to write visited. So we need to have some sort of visited array. And then we also need to have some sort of mention of like whether they've exited the room an odd or even number of times. So we also need an exited array of some sorts. Okay. And now this is basically the rule-based engine or decision-making thing, which, if you like, which basically decides how it leaves a room. So if the visited is an odd number of times, then they will leave through the exit, which is marked by the first letter alphabetically. So we can basically just like write it straight up into an if loop. So if the number of visits, mod 2, is equal to 1, which basically means that it's odd, then we basically leave through the first exit, which is alphabetic. So assuming we've ordered all the exits alphabetically, we basically just return the first element of that list. And then if it's an even number of times, then we leave through the first exit alphabetically that they have left through an odd number of times. I'll highlight this again. Okay, that looks like a frosted out, but it's already highlighted, but it's very important. So we leave through it the first exit, which they've left an odd number of times. So out of all the exits within that particular element, within visited, whichever one of those elements it has been exited out of an odd number of times, that's the thing we exit. And then we also have this one final if loop here. And then I'll just show you the code for this particular function right here. Okay, so basically, for this one, this function's on the get next location. I'll explain how exactly this is being used later, but pretty much if the visits number is odd, then we return the first element, since all the exits are arranged alphabetically anyway. And then we also increment that particular exit value by 1, since we've exited out of that particular room once, and then we return that particular room, okay? Otherwise, if it's even, then what we do is we basically we basically iterate through every single exit within the room, and then if that particular exit has been exited an odd number of times, then we break, since that particular room is going to be the one which we're going to exit out of. However, one more thing which we have to check of is if that particular room, we need to basically check this alphabetic condition. So I'll just go back to the question. The alphabetic condition basically states that if that exit, if the last exit alphabetically in this room, then they will leave through it. Otherwise, they'll leave through the next exit alphabetically. Okay. So if that's the last one, so i.e. if it's a -1, i.e. the last element, then they'll leave through that room. Otherwise, they'll leave through the last exit +1. So it's basically I +1. So that's basically this part of the code. That's this whole section done. Okay, and then I won't go through the example which they gave. I'm sure you can go through that with the current information which we have above. But what I will go through is the second main part of the question, sorry. So this part of the question is basically how the plan is being generated. So the plan is basically how is the sequence of rooms which the person visits. So it basically consists of R rooms, which is denoted by the first R letters of the alphabet. Okay, and now how they construct this plan is they'll basically choose the first room alphabetically, which has not yet been chosen over here. Okay, and then which is not in the plan. So both of these conditions need to be met for them to choose that particular room. And then that particular chosen room is connected to the first room of the plan. Excuse me. And then they basically just repeat this. So since we're repeating this, we can just, if we find some sort of function to carry out this particular line, we just put this in a for loop until every single room has been visited. Okay, so, and then after all the rooms have been visited, then there will be two rooms which haven't yet been chosen. And these two rooms are then connected together in the plan. Okay, so let's just look at how I implemented this part as well. So if we just scroll down a bit, it's in the create plan function. So basically, we iterate through this exactly how I said. And then the way we decide is we get the first plan alphabetically inside the plan. And then what we do is we basically remove that. So then we set plan to equal all the elements right of plan. And then what we do is for letter and result in chosen.items. Okay, so chosen is basically just a set of each of the elements, each of the first letters inside the alphabet, and whether they've been chosen or not, i.e. like whether they've been chosen to be part of the plan or not. So it's a dictionary which stores false or true variable corresponding to each letter, whether they've been part of the plan or not. So if that particular, if result is not, if it's not chosen, and if the letter is not in the plan, and if the letter is not equal to the first room, then we basically set the room to equaling letter, and then we break. So as you can see, this line literally just reads like English, exactly how they asked us to do it. So that's how we decide the particular room, and then we set chosen of that room to equaling true, since that room is now part of the plan. And then what we do is we basically we append that room as being connected to part of the first room's exits, and then as well as the exits of this particular room, we append the first room. Since an exit is basically bidirectional, you can an exit to one room is also the exit from the other room to itself. And then finally, after we're done with all of this, what we do is we basically need to check for the final two elements which haven't yet been chosen. So we iterate through every single room, and then if not result, i.e. if it's not been chosen, then we append it to the not chosen array. And then finally, for the two elements of the not chosen array, we connect them to each other. So we set the rooms of both of them, i.e. the rooms is basically just stores the exits of both of them, and then we append the corresponding rooms to each of them. Okay, so that's basically the question which we've gone through. And in going through the question, we've also gone through two of the main functions enrolled. But in case, it might appear like we're going backwards, but this is probably the most logical order to go through the things in. Here we have the initialization function, which is basically, it stores all the visited visits, it stores the number of visits, as we discussed earlier, to have some sort of array which keeps track of this. And then we also have the exits for each of the rooms, and then we also have a store of each of the rooms. And now the exits of each room basically stores which rooms are connected through each room's exits, and then the room stores which rooms are adjacent to the certain room which we're currently on. Okay, and that's pretty much these three functions, the top three functions. And those three, this is like 95% of the program. And these two final ones are just finishing touches, if you like. So the move function basically just leverages the get next location, which we've already gone through. So the next location from a certain room is whatever the current location is, and then we apply the get next location function to that current location, and then that becomes the next location. And then we increment the visits count of that particular room, and then we set the current location to equaling next, and then this basically just repeats again and again. And then I'll go through this output function a bit later, But before that, what we do is we basically just carry out the move function q times, where q is greater than p, where q is the total number of moves which we have to carry out. And then finally, if I is basically p minus 1 or q minus 1, then we basically need to output the location. Since remember the problem, we basically need to output the location in the q and p moves, q and pth moves. And then finally, we have this output function. This basically just outputs the current plan. So we basically just go for each of the rooms, and then for each of the rooms, we just print them all like joined up together. So that's pretty much it for this particular code. I really hope you enjoyed watching this video. Hopefully you learned something new. And if you did, please be sure to check out my GitHub as well. You can play around with this code yourself, and it will definitely help you a lot if you didn't quite understand my explanation of it. And that's pretty much it for this particular video. Thank you very much for watching. If you want to see similar British Informatics Olympiad videos, I've pretty much done all of them now on the channel. So yeah, check out another one, and I hope to see you in another video next time. Thanks for watching. Bye.